Hey guys, welcome to Tekne Learn. So in this video, we're going to run through the 8 essential skills that you need to start leveling up your parametric design in Grasshopper. My name's Jack, I'm an architect and parametric designer, and I run Tekne Lab, which is a consultancy that works with architects, engineers, and all types of designer to help them with advanced computational design projects. I also run Tekne Learn, which is a Grasshopper coaching platform designed to work one-on-one with you to improve your Grasshopper skills. I've been using Grasshopper for well over 12 years now, and I can honestly say that if I had this advice, understood these concepts earlier on, I would have shaved literally years of getting to the level that I'm at now. So I can guarantee that following this advice will get you from 0 to pro faster than any other method out there. So here are my 8 essential skills that you need in order to start mastering Grasshopper. So it's important to understand that we repeatedly use and manipulate the same types of elements over and over again in Grasshopper. And these are numbers, points, vectors, planes, curves, grids, surfaces, solids, and as an overall term for how everything is organized, are data structures. It seems simple enough, but I find that people tend to miss out just having a simple explanation and understanding of the types of elements that we find in Grasshopper, how they're made up, what we do with them, and the differences between them. So very quickly, numbers are our most basic element that we work with. They are just that, a number. We have to conceptually give them a unit. It could be a unit of distance, rotation, sunlight hours, whatever. We can take 3 numbers, piece them together as an XYZ coordinate to create a point. This is a location in 3-dimensional space. A vector is very similar. The actual annotation between a point and a vector is identical, but a vector defines a direction in 3-dimensional space rather than a location. Planes are flat and extend infinitely in 2 directions and define a local coordinate system. Curves are single or multiple lines joining 2 or more points together. They can have 0 curvature, like a polyline, or have different mathematical formulas for curves to connect them, like NURBS or interpolated curves. They can also be open or closed, like a circle or polygon. Grids are a collection of curves and points set out in a 2-dimensional plane defined by length and width dimensional values. Surfaces are made up of 2 or more curves or corner points and defines a coordinate system over a curved or flat boundary. Solids, also referred to as boundary representations or BREPs in Grasshopper, are volumetric objects with 3 dimensions. And our lists and data systems are how Grasshopper organizes all of our other elements. So by having a solid understanding of what these elements are, you open up your ability to think more strategically and approach problem solving in ways you might not have thought of before. As a larger point that we'll come back to, you will also notice that the order of these elements increases with complexity. That is, simpler elements define more complex elements and objects. When we script, we should be thinking to build relationships and complexity throughout our script from left to right. Most people starting to learn Grasshopper come from a 3D modeling background, so there's a tendency for students learning to jump straight into complex objects like solids immediately. And this is tough geometry for Rhino and Grasshopper to work with, so scripts quickly become bogged down and tediously slow. Parametric design is more about the relationships between objects rather than the object itself, and relationships can always be defined from a numerical basis. Numbers and number systems are therefore the foundation of everything that we do in Grasshopper, everything. Once you start to define your scripts from a numerical basis, everything becomes a whole lot easier. Numbers define points, points define curves, curves define surfaces, and so on, building complexity like we mentioned before. You start to see objects and structures defined by patterns of relationships and numbers rather than actual geometry itself. Numbers and number systems, therefore, are the skeleton from which everything else hangs off. By working like this, and starting to think like this, your scripts immediately become more logical, cleaner, and more efficient. Start off simple by exploring different ways to create number systems. The series, the range, and the random are great ways to create number systems, and look into how you can manipulate these in order to create and affect geometry. So this idea of designing with numbers is so important to Grasshopper definitions and parametric design in general. It's going to take up 2 spots on this list. So once we are comfortable thinking in numbers, thinking about number systems and numerical relationships, we immediately need ways to manipulate these numbers from one system to another in order to generate more complex geometrical arrangements. Take this simple attractor script, for example. The radius of each circle is defined by its distance to a common point. Each circle is a unique distance, so we'll have a unique radius. Pretty simple. The upper and lower boundaries of these distances is 1 to 3 in this example. This is our number system, and all our distances fall somewhere on that scale. I'm sure you've done these before, but why this is so foundational to parametric design is so important and missed by lots of students. So the relationships of these numbers that we're creating means nothing if we have no control over the scale or the units of the system. For instance, we might want to invert the relationship so the closer circles are larger. We could translate our system of 1 to 3 therefore to say 2 to 0.5. The proportions stay the same, but what we're doing is switching our number system and redefining and manipulating our number system rather than the geometry itself. So what if we take our system and translate these numbers to a rotation instead, or an extrusion height? What we gain by starting to think like this and work like this is the ability to control geometry through manipulating numbers and number systems. At its most basic, this is really all you need to know about parametric design. There are levels and levels of skill and technique and complexity on top of this, but essentially this is the logic. Start exploring this idea of a number manipulation by looking at the graph mapper and the remap components to begin to understand how to manipulate both the upper and lower boundaries of numbers and translate units from one system to another. So understanding lists and data structures is probably by far everybody's biggest struggle in the beginning with Grasshopper. Understanding how and why Grasshopper organizes data in the way it does is what's stopping you from creating very efficient scripts. Scripts that take advantage of Grasshopper's data structures rather than having to copy and paste the same script all over the Grasshopper canvas. I won't lie, these are hard concepts to get your head around. Deep explanations of these structures are again very often missed from tutorials, leading to a lot of confusion and misunderstanding with clients. So if you're still randomly flattening and grafting inputs and outputs in the hope of making a script work, then stop. Take some time to study how data is structured in Grasshopper and follow some example sessions that really explain what's going on. Now this is way too big of a subject for this video, but 3 pieces of advice that I can give you and that I would have loved to have known in the beginning are as follows. Number 1, imagine that the data tree conceptually is the same as the folders or filing system that you have on your computer. Each folder or branch in the data tree is separate from the rest, allowing different or the same things to happen in each folder simultaneously without affecting each other. Number 2, Graph adds branches or subfolders to our data tree, giving us more structure and organization. Whereas flatten removes all branches or folders from our data tree, so we just have one folder structure with everything in. Now you can't imagine having one folder on your laptop with all of your files in. This would be a nightmare to navigate and organize. So the idea of having branches is a way of organizing our structures or folders, so we can find and manipulate things in different ways. Number 3 is that lists are automatically adjusted by Grasshopper to be the same length. For example, if you have one point being moved by 10 vectors, the point will technically be repeated 9 more times so that the points list matches the length of the vector list. This is known as longest list mapping and is Grasshopper's default behavior. And understanding this logic can help stop Rhino from exploding when you accidentally repeat something 100,000 times without realizing because of this behavior. These are just a couple of tips, but really with enough time and the right practice sessions, this eventually will all become second nature to you. If you really like some advice on what sessions will be good to start with, reach out and I can point you in the right direction. If you're finding this video helpful, please make sure to drop a follow. You can also head over to our Instagram page where we're always posting more bite-sized tips, tricks and lessons to help you out. There are also lots of free sessions and resources on our online coaching platform, and you can become part of our growing Grasshopper community by joining our free Discord channel. All the links for these you can find below the video. So by this point, we know a lot about Grasshopper, number systems, and our lists and data structures, but there's still a big piece missing from our skills that in reality not a lot of people talk about. And this is what I call parametric design thinking. And it's really the ability to take an idea or design and translate this into a Grasshopper definition. Practicing often is really the main factor here, but also developing a repeatable approach and methodology is going to help you build the skills you need to create definitions from the beginning on your own. But how do we really take a big problem or project and build this up as an efficient Grasshopper script? Clearly, trying to tackle the whole thing at once is going to be overwhelming, so simply by breaking the big problem down into multiple smaller steps, this is going to help us concentrate on one small task at a time. And these small tasks build up and aggregate together to form the whole. So my advice on how to do this is as follows. Number one is your strategy. Think of a general strategy of how you might go about building the object or the project. Ask questions like, are there single or multiple objects being created? Are the geometries all the same, uniform, non-uniform, or random? Will you build the object in position or move and transform it into the final location? Is there an obvious grid setting out of the arrangement? What parameters do I want to keep parametric? The height, the width, the length, any rotations? The idea is not to work out exactly how you're going to create the script, but just to start thinking about how you might go about it. In general, what you come up with is going to be wrong, but that doesn't matter. It's just giving you a place to start. Number two is our control geometry. Think about the most basic geometries that can be used to define the object. This should be no more complex than a point, a plane, a line, a grid, or a curve, or a polyline, or combinations thereof. This will be your base or your control geometry from which everything else hangs off. Starting with a surface or a solid is inevitably going to lead to a heavy script, so we need to start off simple. So number three is storyboarding. Sketch out and storyboard the individual steps leading off your control geometry that you think you can tackle one at a time in Grasshopper. Keep in mind the general rule of complexity that simple objects build more complex objects. Again, these sketches will be wrong, but at least they'll give you something to start with that you can edit and change whilst in Grasshopper. So it's normal for this to take a couple of rounds of thinking and sketching to get something working like you expect. I know it seems like a lot of work, but the aim is to focus your attention on small tasks that aggregate to form the bigger picture. And it's these parametric design thinking skills that I believe take the longest to develop in Grasshopper. Following tutorial after tutorial won't teach you this. You need to practice developing and building your own portfolio and projects in order to start getting somewhere. Start basic with some simple projects and build up the complexity and sophistication of your skills from there, just like your Grasshopper scripts themselves. So understanding curves and their properties is worth taking the time to understand because it really goes hand in hand with our understanding of numbers and number systems. You may have noticed in Grasshopper that you see the domain 0 to 1 very frequently throughout components. And if not, keep an eye out because this is an important point. And the reason really comes down to how we understand geometry, and more specifically, normalized or reparameterized geometry. So when we're working with normalized or reparameterized curves, the start of the curve will always be 0, and the end of the curve will be 1, no matter what the actual length of the curve is. If the curve is 1 meter or 1 kilometer, a value of 0.5, for instance, is always going to be the precise midpoint of the curve. Understanding this gives us a huge advantage as we can plot very complex settings out by simply defining a range of numbers spread between 0 and 1, no matter the curve, no matter the scale. And once we understand this one simple fact about curves, it opens up so many different ways of working and dividing up geometry based wholly just on simple number sequences. Extending what we now know about curves further, the way that Rhino understands curves and surfaces is actually not all that different. Essentially, a surface is a curve, but with two axes, giving us a coordinate space over the surface which is known as the U and the V directions. This UV coordinate system works exactly the same for all valid surfaces, whether it's a square, a rectangle, if it's circular, if it's curved, it doesn't make a difference. So now we know that topologically speaking, all surfaces are the same, we again can normalize or reparameterize our surfaces so we can understand their U and their V directions to be between 0 and 1. So just like we can with curves, we can also divide our surfaces based yet again on simple number ranges spread between 0 and 1, no matter the surface, no matter the scale. Understanding surfaces and their properties like this makes complex paneling much easier and much more intuitive, and something that we can accurately control all with native Grasshopper components and without the use of any plugins that we don't really understand. Having a deeper knowledge of surfaces in this way took me years to understand as well as I do now, and so I didn't really realize the importance. I relied way too much on other plugins, which, although can be useful, I believe actually reduce our understanding of how Grasshopper works with geometries. By getting to grips with these concepts of surfaces, you will advance your Grasshopper skills far, far quicker, as you'll actually understand why and how we work with surfaces in certain ways to create complex definitions. Solids, or boundary representations, BREPs, as you will see Grasshopper refer to them, are our last stop, as they should always be the last thing that you do while scripting in Grasshopper. Everything from numbers to points to curves to surfaces is all about creating the skeleton, the relationships and the structure between elements in our parametric definition. Working with these simple elements will keep Rhino and Grasshopper happy and efficient. Solid objects then are the final flourish, the skin and the muscles that hang off our complex skeleton. However, like I said earlier, people tend to jump to solids way too early and end up creating heavy, inefficient definitions that take a very long time to compute. So as a starting point of working with solids, I would first even ask myself if I need them at all. What is my required output, and can the same be achieved just with surfaces and curves? This is always going to be project dependent, so it's really up to you to judge whether you need to go this far with your scripting. Of course, the thicknesses of frames and other volumetric objects, for instance, plays a part in how everything is set out. But as much as possible, these relationships should be defined with numbers, curves, and surfaces beforehand, not from creating any solids themselves. Limiting the use of heavy geometrical elements like this right until the end will generally save you a huge amount of time. So I hope you found this advice and these steps helpful. Each one requires careful study and practice sessions designed to help make these concepts stick. But by focusing on them and taking them seriously, I guarantee that you'll advance your skills by years compared to those who are just aggressively following tutorials. Like I said, I've been using Grasshopper for a long time, and I honestly wish I'd taken the time to understand the importance of these concepts earlier on. Take the time to learn some foundational concepts of Grasshopper, parametric design thinking, and geometry, and you'll quickly become a true parametric designer capable of building anything you can imagine in Grasshopper. So thanks so much for watching. Again, if you found this video helpful, please drop a follow and head over to our Instagram. Like I said, we're always posting more bite-sized content for you to learn from. And don't forget to join the free Tekne Grasshopper community hosted on Discord, all the links for which are below.